Okay, hello everyone. In this video, we are going to discuss about properties of inverse Laplace transform and corresponding numericals. In our last class, we have been discussed inverse Laplace transform of elementary functions. These are the 16 elementary functions whose inverse Laplace transform we have been discussed in our last class, and I suggested that you have to remember the Laplace transform and corresponding inverse Laplace transform of these 16 elementary functions which is most essential to solve the numericals. How to remember easily these 16 elementary functions corresponding Laplace and inverse Laplace transform, that also we have been discussed in our last class. Now we are going to go towards today's discussion about properties of inverse Laplace transform and corresponding numericals. Okay, so first property is your linear property, and what will be the inverse Laplace transform of this property, that we are going to discuss first. Then change of scale property, then shifting property, and corresponding numericals also we are going to discuss. So let's start. The first property, whatever we have been discussed already, that is your linear property. That according to this property, Laplace transform of C1 F1t plus C2 F2t, here C1 and C2 are constants, will be equal to C1 capital F1s plus C2 capital F2s. That implies inverse Laplace transform of this one will be equal to this original function, that is your C1 F1t plus C2 F2t. Now we are going to go for numerical based upon this property. This is the numerical that finding the inverse Laplace transform of 4 by s to the power 3 plus 18 by s to the power 4. So inverse Laplace transform of this one can be written as 4 is constant taken outside, inverse Laplace transform of 1 by s to the power 3 plus 18 also taken outside as it is constant, inverse Laplace transform of s by s to the power 4. For inverse Laplace transform of this s to the power 3 can be written as 2 plus 1, s to the power 4 can be written as 3 plus 1. We know that inverse Laplace transform of n factorial by s to the power n plus 1 equal to t to the power n. Already we have been discussed this one. Okay. Or inverse Laplace transform of 1 by s to the power n plus 1 will be equal to t to the power n by n factorial. If I am going to compare this one with respect to this one, then here n equal to 2. So inverse Laplace transform of 1 by s to the power 2 plus 1 will be equal to t to the power 2 by 2 factorial. T to the power 2 by 2 factorial. Likewise for this case, it will be t to the power 3 by 3 factorial. So hence our answer will be this one. Here 4, 2 factorial means 2, 2, 4 dot cancel. That means here 2 will be remaining, 2 t to the power 2 plus here 3 factorial means 3 into 2 6. 6 18 if going to be cancelled or going to divide, then we are going to get 3 t to the power 3. This is the answer of this question. Okay, next we are going to go for inverse Laplace transform of change of scale property. By this property, we know that Laplace transform of f of at equal to 1 by a capital F of s by a. Here, Laplace transform of f of t equal to f of s, capital F of s, or we can say inverse Laplace transform of capital F of s will be f of t. So according to this property, if this equal to this, so obviously inverse Laplace transform of this one will be equal to original function, that is your f of at. That implies inverse Laplace transform of capital F of s by a will be equal to this a will be multiplied with this one, a into f of a t. Now we are going to go for a numerical, that finding the Laplace inverse Laplace transform of 4 by s to the power 2 plus 4. Okay. This question can be solved by using this property, change of scale property. How? We know Laplace transform of sin t equal to 1 by s square plus 1. Okay, because we know Laplace transform of sin at equal to a by a square plus a square. So if a equal to 1, so it will be 1 by a square plus 1. Therefore, Laplace transform of sin a t, that means sin t only, here a equal to 1, the Laplace transform will be 1 by a square plus 1. So obviously inverse Laplace transform of this one will be sin t. Okay, so here if this one will be considered as your capital F of s, then we can get f of t. So this is your capital F of s, and f of t is nothing but sin t. Now we have to consider if s by a, if we are going to consider s by a, that means if we are going to consider f of s by a, so obviously right hand side will be a into f of at according to this property. Inverse Laplace transform of f of s will be equal to f of t. If inverse Laplace transform of f of s by a will be there, then answer will be a into f of at. Okay. Now, the question is given as inverse Laplace transform of 4 by a square plus 4. This 4 by a square plus 4 can be written as 1 by s by 2 square plus 1. Okay, so here you can compare that this one, this with this. We can found that here s is there, here s by 2 is there. Now you compare this with this, again this. So if I am going to compare this with this, then here a is your 2. Okay, if capital F of s is there, f of t we have to get the answer. If s by a, that means this one is your capital F of s by 2 is there. So answer will be 2 into sin 2t, because f of t is the answer of inverse Laplace transform of capital F of s. Okay, so if we are going to consider inverse Laplace transform of f of s by 2, then the answer will be 2 into sin 2t according to this property. So answer will be inverse Laplace transform of 1 by s by 2 square plus 1, or inverse Laplace transform of this one will be equal to 2 into sin 2t according to change of scale property. Okay. Next we are going to go for shifting property, or this is also known as fast shifting theorem corresponding inverse Laplace transform and numerical. By this property we know that Laplace transform of e to the power at into f of t equal to f of capital F of s minus a, where capital F of s is nothing but your Laplace transform of f of t. Inverse Laplace transform of capital F of s equal to f of t. Right? So if Laplace transform of this one equal to this, then obviously inverse Laplace transform of this one will be equal to e to the power at into f of t. See, Laplace transform of f of t is your f of s. If I will be apply both the side inverse Laplace transform like this, inverse Laplace transform applied on the left hand side, and inverse Laplace transform also applied on the right hand side. So here Laplace, here inverse Laplace. So this will be cancelled out, means it will be 1. So f of t will be equal to inverse Laplace transform of capital F of s. Okay. So inverse Laplace transform of this one will be equal to this function. Here function is nothing but e to the power at into f of t, as we know according to your shifting property or fast shifting theorem. Right? Now we are going to go for a numerical. Find inverse Laplace transform of 1 by s plus 2 to the power 5. How we are going to solve by using this property? Here Laplace transform of e to the power n, we know that n factorial by s to the power n plus 1. So if we are going to consider n equal to 4, so obviously this will be 4 factorial by s to the power 4 plus 1, or 4 factorial by s to the power 5. That implies t to the power 4 If I may apply inverse Laplace transform both the side, then this will be t to the power 4 equal to inverse Laplace transform of 4 factorial by s to the power 5, right? That implies inverse Laplace transform of 1 by s to the power 5. This 4 factorial will be divided with this term. So it will be 1 by 4 factorial into t to the power 4. Now, inverse Laplace transform of 1 by s minus of minus 2 to the power 5. That means whatever the question has been given, s plus 2 can be written as s minus of minus 2 to the power 5. Right? Laplace transform of 1 by s to the power 5 is nothing but 1 by 4 factorial into t to the power 4. Or we can say that this is your inverse Laplace transform of capital F of s equal to the so-called small f of t. But as per the question, if we are going to consider, in the question it has been given that s plus 2, the s plus 2 can be written as s minus of minus 2, right? So that means this one can be considered as capital F of s minus a. Okay, so inverse Laplace transform of capital S minus a is nothing but e to the power at into whatever the initial function, that is your f of t. So here initial function is nothing but t to the 4 by 4 factorial will be multiplied with e to the power minus at, sorry, e to the power at. So here a, if I am going to compare, here, uh, if I am going to compare this with this, here a is nothing but minus 2. So e to the power minus 2t into the function f of t is nothing but t to the power 4 by 4 factorial. Okay, so inverse Laplace transform of given question, that is your 1 by s plus 2 to the power 5 will be equal to e to the power minus 2t into t to the power 4 by 4 factorial. Okay, no need to write this one. Okay, next question is that find the inverse Laplace transform of s by a square plus 4s plus 13. How we are going to solve this numerical using shifting property? Here is the answer. Laplace transform of this one, s can be written as s plus 2 minus 2 whole divided by this one. This can be written as s plus 2 whole square plus 3 square. Okay, see, s plus 2 whole square is nothing but, here s plus 2 whole square, s plus 2 whole square is nothing but a square plus 2s plus 4 plus 3 square is 9. That means a square plus, sorry, s plus 2 whole square is a square plus 4s. Okay, plus 4s plus 4 plus 9. So a square plus 4s, a square plus 4s, 9 plus 4 is your 13. So denominator can be written as s plus 2 whole square plus 3 square, right? Now this can be written as s plus 2 divided by this one minus 2 divided by this one. So inverse Laplace transform of s plus 2 by s plus 2 square plus 3 square minus inverse Laplace transform of 2 by s plus 2 square plus 3 square, right? Now here you can see inverse Laplace transform of s by a square plus b square is nothing but cos bt. Already we know here cos 80 is there, that means s by a square plus a square, b will be there, means s by a square plus b square. S by a square plus b square will be cos bt. Inverse Laplace transform of b by a square plus b square will be sin bt, that we know. Inverse Laplace transform of s minus a, see, this will be considered as capital F of s will be equal to cos bt. If we are going to consider s minus a, see, this is considered as capital F of s. If we are going to consider capital F of s minus a, that means where is the s? We have to consider s minus a. So here instead of s if we can write s minus a by here s minus a square plus b square. So according to shifting property, this value will be e to the power at into cos bt. Likewise, Laplace transform, inverse Laplace transform of b by s minus a square plus b square will be equal to e to the power 80 into sin bt. Here I mistakenly written. So e to the power 80, e to the power 80 into sin bt, right? Now inverse Laplace transform of, here you can see s plus 2 is there. S plus 2 can be written as s minus of minus 2. This one can be written as s minus of minus 2 whole square plus 3 square. So here a is nothing but minus 2. Here a, instead of a, minus 2 is there. So answer will be e to the power minus 2t cos, here 3 is there, here instead of b 3 is there, so cos 3t. Likewise, if I am going to compare this and this, instead of a, minus 2 is there, instead of b 3 is there. Sorry, instead of b, instead of b, instead of a, 2 minus 2 is there, instead of b, 3 is there, but on the numerator there is no 3. So only for that we have to multiply a 3, divide a 3. So 2 taken outside, 2 by 3, 3 multiplied and 3 divided. So 2 by 3, 3 by s minus of minus 2 whole square plus 3 square. So compare this with this. B is 3, A is your minus 2. So the answer will be e to the power 80 into sin bt. Already 2 by 3 is there. 2 by 3 into e to the power minus 2t into sin 3t. So combiningly, if we are going to write inverse Laplace transform of this one equal to e to the power, see, e to the minus 2t is common for this and this taken outside. So this will be cos 3t minus 2 by 3 into sin 3t is the answer. Okay, so here is the another question for you that you have to solve by yourself, that inverse Laplace transform of s plus 1 by a square minus 6x plus 25. Do by yourself. Answer will be e to the power 3t cos 4t plus sin 4t. Exactly this procedure you have to consider. Okay, so we have to move to another property, next property, that is your Laplace transform of derivative. So here I suggest one thing, that carefully you have to write your notes. Okay, so here I multiplied e to the power 80. So here I just put it the bracket. Okay, e to the power 80 into sin bt. Don't be confused. Next, inverse Laplace transform of derivative. By this property, we know that Laplace transform of first derivative of a function is nothing but s capital F of s minus f of 0. Here is the small f of 0, right? That implies Laplace transform of f dash t will be equal to s. This also can be written as Laplace transform of f of t minus f of 0. Hence, inverse Laplace transform of right hand side, that is your s into Laplace transform of f of t minus f of 0 will be equal to this one, f dash t. Okay, so inverse Laplace transform of s into this much, s into Laplace transform of f of t will be equal to f dash t is there. So left hand side inverse Laplace transform of f of 0 taken this side, it will be plus inverse Laplace transform of f of 0. That implies inverse Laplace transform of this one, s into this also can be written as capital F of s will be equal to, this is your d by dt of f dash t is nothing but d by dt of f of t. Here is the small f of t, okay, plus f of 0 into delta t. See, inverse Laplace transform of f of 0, we know that in general f of 0 into delta t. Okay. See, some books are written only f of 0, some books are written delta t. There is no problem because we know that delta t is nothing but delta t minus 0. Okay, so delta t minus 0 value is 1 when t equal to 0, 0 elsewhere, like this. At t equal to 0, it is exist, that means its value is maximum, otherwise it is 0. Ideally delta t, if I am going to consider, so here f of 0 value exists at 0 and delta t value at 0 is 1. So instead of writing delta t, we can write itself 1. So some books written in this format, some books not written delta t, only written f of 0, I written delta t. Okay, so now we are going to apply this property to solve the numericals. So find first this first numerical, that inverse Laplace transform of s by s square plus 1. This numerical is going to be solved with the help of this property, that is your Laplace transform of derivative. See, each property, after each property I done the numerical corresponding of that property. Okay, so you should not be confused. In systematic way I have been done this one. You also write in your note in this systematic way, will be useful for your exam, right? So inverse Laplace transform, this can be written as ac into 1 by s square plus 1, right? This can inverse Laplace transform of s into 1 by s square plus 1 is your f of s. See here, f of s is nothing but your sin t. How? Inverse Laplace transform of 1 by a square plus 1, we know that sin t only, that is your f of t we have to consider. So inverse Laplace transform of s into 1 by a square plus 1 will be equal to, if I am going to compare, if I am going to compare this one, this expression with this expression, here s is there, here fs is nothing but your 1 by a square plus 1, right? So if it is so, then answer will be d by dt of f of t. So here f of t is your sin t, d by dt of sin t, then f of 0. F of 0 means f of when f of t for t equal to 0. So f of t equal to sin t. So if t equal to 0 means sin 0 we have to consider into delta t. Sin 0 itself 0, so this term will be 0. If I do the derivative with respect to t, sin t will be cos t. So answer of this question is nothing but cos t. It is very simple. We know that this answer will be cos t in our elementary functions. Okay, next question is your inverse Laplace transform of 3s by 2s plus 9. So how we can write first s into 3 by 2s plus 9. So this is your capital F of s into s. So if I am going to compare this one, so if I am going to compare this with this, here s is s, here fs is your 3 by 2s plus 9, right? Now what will the inverse Laplace transform of f of s? So inverse Laplace transform of this one is your capital F of s. So first we have to find out what will be the inverse Laplace transform of this capital F of s. So here you can see uh, uh, 3 by 2 taken outside, that means 3 taken from the numerator, 2 taken from the denominator. So 3 by 2 inverse Laplace transform of 1 by, here s 2 taken outside, here 2 taken outside means 9 by 2, 3 by 2, yes, in 1 by s plus 9 by 2. Now we are going to consider this one. Here you can see that inverse Laplace transform of 1 by s minus a equal to e to the power at. Okay, so this also can be written in that format, s minus of minus 9 by 2. So here if I am going to compare this 1 by s minus a and its inverse Laplace transform will be e to the 80. So here a, if I am going to compare with this one, here a is your minus 9 by 2. So the answer will be 3 by 2 into e to the minus 9 by 2t. So this is your f of t, what we are searching for initially. But according to this property, Laplace transform of derivative, the answer will be d by dt of f of t plus f of 0 into delta t. Right? Now, inverse Laplace transform of this one will be equal to d by dt of f of t, 3 by 2 into e to the minus 9 by 2 into t plus 3 by 2 into f of 0. F of 0 means wherever the t we have to put 0. If I will put 0 here, then 3 by 2 into e to the minus 9 by 2 0. So obviously e to the 0 will be come up and e to the 0 will be 1. And delta t, I told that delta t, some books are written and some books are not written, because we know that delta t value will be 1 at particularly uh, 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 at 0. If delta t minus a will be written, if t minus a, its value will be 1 at t equal to a, 0 elsewhere. But delta t, if has been written, delta t value will be 1 when t equal to 0. So here delta t will be 1. So e to the power 0 will be 1. We have to substitute. So this will be derivative with respect to t. This term will be how much? 3 by 2 is already there. So e to the power minus 9 by 2 t differentiated with respect to t means minus 9 by 2 into e to the minus 9 by 2 t plus 3 by 2. Here e to the power 0. Now this one will be 27 by 4 e to the minus 9 by 2t plus 3 by 2 is your answer. Okay. Now we are going to go for the next property, that, or we can say inverse Laplace transform of integrals. Here inverse Laplace transform of derivative. Here inverse Laplace transform of integrals. Okay, this is your fifth property. Okay, by this property we know Laplace transform of 0 to t f of t dt equal to 1 by s into capital F of s, where capital F of s is nothing but Laplace transform of f of t. That implies inverse Laplace transform of this right hand side will be this original function 0 to t f of t dt. Now we are going to go for the numericals based upon this property. Find inverse Laplace transform of 1 by s into s plus a. How we are going to solve it using this property? Here you can see. The given question can be written as 1 by s into 1 by s plus a. Inverse Laplace transform of 1 by s. This 1 by s plus a is your nothing but capital F of s. First we have to find out what will the inverse Laplace transform of this f of s or 1 by s plus a. Inverse Laplace transform of 1 by s plus a is nothing but e to the minus at. We know that just now we discussed that inverse Laplace transform of 1 by s minus a. Here a is minus a will be equal to e to the power at, and here a is nothing but minus a. So e to the minus at, which is your f of t. Okay. But if I am going to compare this with this, then answer will be 0 to t f of t dt. Here f of t we found e to the power at. So inverse Laplace transform of this one, if I am going to compare this with this, then equal to 0 to t f of t is nothing but e to the power at, e to the power at dt. Just integrate it and we are going to get the answer 1 minus e to the minus 80 by a is your answer. Now likewise, another question, 1 by s into a square plus 1 can be written as 1 by s into 1 by a square plus 1. Inverse Laplace transform 1 by s into, this is your capital F of s. So inverse Laplace transform of this one or capital F of s, 1 by s square plus 1 will be equal to sin t, which is your f of t. According to this property, 1 by s f of s will be equal to 0 to t f of t dt. So inverse Laplace transform of this one will be equal to 0 to t sin t dt will be equal to minus cos t plus 1 is your answer. Likewise, another question is your inverse Laplace transform of s square plus 3 by s into s square plus 9. So this can be written as 1 by s into a square plus 3 by a square plus 9, right? But inverse Laplace transform of 1 by s a square plus 3 by a square plus 9 can be written as inverse Laplace transform of c. The numerator a square plus 3 can be written as a square plus 9 minus 6 whole divided by ac into a square plus 9, whatever it already is there. Inverse Laplace transform of 1 by s. See, this can be written as or this can be rewrite with by considering partial fraction. Okay, by using partial fraction. So here this can be written as 1 by s minus 6 by s into a square plus 9. You just subtract it. We are going to get this one. This one. Okay. Here you can see the LCM will be s into a square plus 9, and here will be a square plus 9 minus uh, minus 6s. Sorry, minus 6 only. Okay. So these two terms separately can be written inverse Laplace transform of 1 by s minus inverse Laplace transform of 1 by s into 6 by s square plus 9. 1 by s inverse Laplace transform is 1. Leave it. Minus 6 is your constant taken outside inverse Laplace transform of this one 1 by s. Here you can see that whenever we are going to take 6 outside, it will be 1 by a square plus 9. So to uh, convert to a suitable function, here I multiplied 3 and divided 3. Now 1 by s is there, 1 by s into 1 by 3 into 3 by s square plus 9. 9 is nothing but 3 square, right? So 1 minus 6, this 3 taken outside, 6 by 3 into inverse Laplace transform of 1 by s into 3 by s square plus 9 or 3 square. Okay, so a by a square plus a square is nothing but sine 80, that we know. Okay, so here if I am going to compare this with respect to this one, here 1 by s, here 1 by s is there, here fs is nothing but this one. Fs is your 3 by a square plus 9. So inverse Laplace transform of this one only is nothing but sine 80. Here a is 3, sine 3t. But according to this property, inverse Laplace transform of 1 by s into f of s will be 0 to t integration f of t dt. So hence minus 1 is there, minus 6 by 3, 0 to t f of t dt. F of t dt. Okay, f of t dt. So 0 to t sine 3t into dt will be equal to 1 is there, 1 minus here 6 by 3 is your 2, and integrating sine 3t will be 1 by 3 minus cos 3t. Cos 3t 0 to t will be the limit, and if we are going to put the limit, the answer will be this one, 1 by 3 plus 2 by 3 into cos 3t will be the answer. Okay, next we are going to go for the next property, that is your derivative of Laplace transform, or here we are going to discuss inverse Laplace transform of derivative of Laplace transform. Okay, derivative of Laplace transform. According to this property, we know Laplace transform of t into f of t equal to minus 1 to the power 1 d by ds of capital F of s. Right, derivative of Laplace transform, where we have been discussed. Here you can see derivative of Laplace transform number f df, this one. In general, we know that Laplace transform of t to the power n into f of t is equal to here minus 1 to the power n nth derivative of capital F of s. When n equal to 1, then it will be t into f of t minus 1 to the power 1 d by ds of capital F of s, whatever I have been written over here. That implies inverse Laplace transform of this one will be, this value will be minus, so minus t into f of t. That implies, here you can see f of t will be equal to this minus 1 by 2 1 by minus t can be will be divided with this one, with this term, so it will be minus 1 by t inverse Laplace transform of derivative of capital F of s with respect to s, where capital F of s we know that Laplace transform of f of t. Now we are going to go for the numericals based upon this property only. Inverse Laplace, we have find out the inverse Laplace transform of ln log ln s plus 1 by s minus 1. Inverse Laplace transform of this one will be equal to see, equal to minus 1 by 2 inverse Laplace transform of d by ds of ln s plus 1 by s minus 1. Don't be confused, here I am going to explain how it is. See, here I have to write one thing, that here that implies f of t will be nothing but inverse Laplace transform of capital F of s. Okay, if capital F of s equal to Laplace transform of f of t, so therefore f of t will be nothing but inverse Laplace transform of f of s, capital F of s. So here it is given in that form, that inverse Laplace transform of capital F of s, like this. If I am going to compare this with this with this, okay, so here inverse Laplace transform of capital F of s is nothing but f of t, where f of t is equal to minus 1 by t inverse Laplace transform of derivative of capital F of s with respect to s. So inverse Laplace transform of capital F of s, this one will be equal to what we can write, minus, here minus 1 by t inverse Laplace transform of d by ds of f of s. Here we consider f of s, capital F of s is nothing but this one, ln s plus 1 by s minus 1, right? So here ln s plus 1 by s minus 1 can be written as s plus 1 minus s minus 1, ln s plus 1 minus ln s minus 1. So derivative of ln s plus 1 minus derivative of s minus 1, ln s minus 1, same thing it has been written, minus 1 by t inverse Laplace transform of d by ds of ln s plus 1 minus d by ds of ln s minus 1. Derivative of this one is will be 1 by s plus 1, this one 1 by s minus 1, minus 1 by t is there, minus 1 by t inverse Laplace transform of 1 by s plus 1, or it is written that 1 by s minus of minus 1. So we know that 1 by s minus a inverse Laplace transform is nothing but e to the power at. So here a is nothing but minus 1. If I am going to compare this with this, then here a is your minus 1. So answer will be e to the minus t. So if I am going to compare this with this one, s minus a, so here a is nothing but 1. So e to the t. So this is t. Okay, this is t. This is t. This is your e to the minus t. So the answer will be this one, 1 by t e to the t. This, so minus will be multiplied with this, means e to the t minus e to the minus t will be the answer. Now next question is that find the inverse Laplace transform of 2as by a square plus a square whole square. This question is solved in a different technique. Here you can you watch carefully. Inverse Laplace transform of this one, 2as by a square plus a square whole square. This one, this term can be written as derivative of this one, minus a by a square plus a square with respect to s. Okay. Now I am going to compare this inverse Laplace transform of this one with this one. So inverse Laplace transform of d by ds of fs equal to minus t of f of t. So here d by ds of this one, here I consider a by a square plus a square is your capital F of s. Here d by ds of capital F of s inverse Laplace transform is equal to minus t, here minus t into f of t. So minus t is there, and then f of t is nothing but inverse Laplace transform of capital F of s. Here capital F of s is nothing but a by a square plus a square. Its inverse Laplace transform is nothing but sin at. Minus is there, so minus will be plus t into sin at. Okay. Next we are going to go for next property, that is your integration of Laplace transform. Actually here we are discussing inverse Laplace transform of the integration of the so-called Laplace transform. Okay. By this property, Laplace transform of 1 by t into f of t equal to integration of capital F of s with respect to ds limit from s to infinite. So that implies inverse Laplace transform of this one will be equal to this one, or we can write inverse Laplace transform of s to infinite limit capital F of s ds will be equal to 1 by t. This f of t is nothing but inverse Laplace transform of capital F of s, we know. Now we are going to consider a numerical based upon this property, that is your find inverse Laplace transform of 2s by a square plus 1 whole square. So here you can see that inverse Laplace transform of 2s by a square plus 1 whole square will be equal to t into inverse Laplace transform of f of s, capital F of s ds integration from s to infinite. See, compare with this one, this with this. Okay, so here inverse Laplace transform of a capital F of s, here inverse Laplace transform of capital F of s will be equal to t into this much. Same thing it has written, t into inverse Laplace transform of s to infinity f of s ds. Here f of s is nothing but this one. Inverse Laplace transform of s to infinity is the limit 2s by a square plus 1 whole square written into ds, right? So t is there, t inverse Laplace transform of if I am going to integrate this one 2s by a square plus 1 whole square, then it will be minus of 1 by a square plus 1 limit s to infinite. Then t into inverse Laplace transform. This is inverse Laplace transform of here you can see that if I will put infinite, then the value will be 0, minus I have to put s, this will be a square plus 1. So minus already is there, so it will be plus. So plus 1 by a square plus 1. So inverse Laplace transform of 1 by a square plus 1, we know that sin t. So answer will be t sin t. So t into inverse Laplace transform of 1 by a square plus 1 will be equal to t into sin t. Okay, here I am doing the integration of this one in my rough. You can see, no need to write in your note the integration of this one. This is very simple. Okay, for you only. Here I'm doing the integration. No need to write in the note. Okay, here you can see that integration of 2s by a square plus 1 whole square ds. Okay, put a square plus 1 equal to suppose t. So 2s ds equal to dt, right? So here 2s ds will be dt by t square, right? So this will be equal to t to the power minus 2 into dt. Okay, if you are going to consider the limit is not going to be changed. See, s to infinity. So if I will be put s equal to s, t equal to s, if I will put s equal to infinite, t also will be infinite. So it will be s to infinite, no changes. So integration of this one will be how much? It will be t to the power minus 2 plus 1 divided by minus 2 plus 1 s to infinite. So this will be minus of t to the power minus 1 s to infinite. So this will be minus of 1 by t, we consider s square plus 1, s square plus 1, s to infinite, this one. Okay, minus of 1 by s square plus 1, s to infinite, minus s square plus 1, s to infinite, right? So here we have to stop our today's discussion. In our next class, we are going to discuss inverse Laplace transform of second shifting property, then inverse Laplace transform by convolution and corresponding numericals. Thank you so much for watching this video. Thank you.